Okay, let's talk about the last new material for this unit. So this is what we would call the working backwards problems, where we give you some information and we expect you to find all the angles. So the working backwards problems, and the key thing to remember is when different things are, all seniors take calculus when we're positive, such as if I said the sine is positive, the tangent's negative, what quadrant or quadrants would that happen in? So you could say, sine is positive. Well, sine is positive in first and second, but then it says tangent's negative. Well, tangent's positive in first and third, so tangent's negative in second and fourth. So when are both of these things true? Second quadrant. So second quadrant. Let me see, cosine's negative. Well, let me see, cosine's positive in first and fourth, therefore cosine's negative in second and third. And then cosecant is positive, greater than 0, positive. Cosecant goes with sine, so cosecant's positive in first and second. So cosecant's positive in first and second. So when are both of these things true? Second quadrant again. Cotan's negative. Cotan goes with tan and it's negative. So it's positive in first and third. So it'd be negative in second and fourth. And then when is secant negative? Secant goes with cosine. So cosine's positive in first and fourth. So secant's negative in second and third. So second and third, secant's negative in second and third. So when are both of those? I didn't mean for all those to end up being second quadrant. Anyway, so that situation will probably show up on the test, but it's also something that's going to come up a lot as we go through the these next set of problems. So you look at something like this, it says when is sine is equal to 1/2. So this is when we're thinking, okay, I got to know my unit circle. I've got to know, okay, when is sine 1/2? Well, hopefully at this point of the show, you're going to know that sine of 30 is 1/2. Similarly, sine of pi over 6 is 1/2. And that's your reference angle, since that's the acute angle. So you think, okay, between 0 and 360, my reference angle is 30. Between 0 and 2 pi, my reference angle is pi over 6. So we said, okay, when is sine 1/2? That's just, we got to start thinking in these terms. But now cosine's also negative. So check it out. Sine is positive 1/2, which could be the first and second quadrant. Cosine's negative, which is only the second and third, which is the second and third quadrants. So when is sine positive, cosine negative? Only the second quadrant. So the actual angle answer, the actual angle that fits this condition is going to be the second quadrant angle with a reference angle of 30. So hopefully at this point, you're saying, oh, that's easy. Reference angle of 30 in the second quadrant is 150. Reference angle of pi over 6 in the second quadrant is 5 pi over 6. So we had to identify the reference angle based on that information, and then the actual angle thetas that fit those conditions. And then they get weirder naturally. I wrote this one backwards. That should be 1, and that should be 3. I wrote it backwards. So let me see, if I'm between pi over 2 and 3 pi over 2, oh, wait a second, pi over 2 and 3 pi over 2 is only the third and fourth quadrants. Agreed? So pi over 2 to 3 pi over 2 is only the third and fourth quadrants. And then it says tangent is -1. Well, first of all, tangent's positive in the third quadrant. So tangent's negative in the fourth quadrant. So I know my answer here is going to be fourth quadrant because tangent's negative in the fourth quadrant, but it's positive in the third. Then I got to say to myself, do I know my unit circle values well enough to know when tan is -1? Hopefully, we're getting to the point where we know this, but that goes back to the 45s. And that would, because it's, that's 1 root 2. So tangent is 1/1, cotan is 1/1. So that makes a reference angle of 45, except the problem is in radians. So we have to answer in radians. So that goes with pi over 4. Then you got to say to yourself, okay, fourth quadrant, who's pi over 4 in the fourth quadrant? Hopefully we are comfortable with this by now, but that'd be 7 pi over 4. This guy down here, from 0 to 270 degrees. Well, at least it's in degrees, and I know y'all like that. 0 to 270. Okay, so that's first through third quadrant. So it could be first, second, third quadrant. Okay, secant's negative. That only happens in the when secant's negative. That happens in the second and third quadrants. Cotan is positive. That happens in the first and third. So it looks like, where does all this match up? So our only answer is going to be in the third quadrant. Our only answer is going to be in the third quadrant. Okay, now the tricky part. When is secant negative 2 root 3 over 3? I'm thinking, what the heck? But hopefully you're going to say to yourself, oh yeah, I've seen this enough times that I remember secant is the reciprocal of cosine. This funky thing here is the reciprocal of root 3 over 2. This guy is the reciprocal of root 3 over 2. And it's negative, but that's not what's hurting my feelings right now. So we know our answer is third quadrant. Then you got to say to yourself, okay, when does cosine get the root 3 over 2? Well, cosine is the root 3 over 2. Where am I? Root 3, 2, 1. So cosine would have to be this guy right here, root 3 over 2. So that happens at the 60s. So it happens at the 60s. And how convenient, since it did ask for radians, I can give an answer in radians, but it'd be pi over 3 if I was asking in degrees, be pi over 3 for in radians. Then you got to say to yourself, all right, oh, but I actually want the third quadrant angle that fits all of these conditions. So the third quadrant angle, who goes with the 60s in the third quadrant? Well, that is 240. So it's one of those, a lot of pieces here, a lot of pieces you got to put together, a lot of pieces. Let's do a couple more. Cosecant's undefined. So hopefully we're going to say to ourselves, cosecant's undefined. Cosecant is a reciprocal of sine. If cosecant's undefined, that means sine must be 0. The reciprocal of 0 is undefined. So when is sine 0? Well, sine is equal to y. On the unit circle, sine is y. So when is y? When is y equal to 0? And we know when we see undefined and 0, we're thinking quadrantal. We know when we see undefined and 0, we're thinking quadrantal. So we're going, but sine y has to be 0. Well, y is 0 at the x-axis, so at 0 and 180, etc. Now, to make this problem even funkier, it says 0 to 4 pi. Well, that's 2 laps. So that would be 2 laps around the circle. First of all, you'd say, well, it's a quadrantal, so there's no reference angle, but we need all the angles that match this for 2 laps. That'd be 0, pi. So we can go 0 to pi, to 2 pi, to 3 pi. And then somebody says, well, what about going all the way to 4 pi? Well, it doesn't say including 4 pi. So it doesn't include 4 pi. So we don't go all the way back to 4 pi. So we just need these 4 right here. Anyway, take some thought. Takes a little thought. The last thing, we have done these problems a million times. I know that's an exaggeration. We've done these problems a million times. You're saying to yourself, oh, this is just a Pythagorean theorem problem. You are correct. If I just drew a Pythagorean theorem problem, I just drew the Pythagorean theorem, but there's a little trick to it, not really a trick. You'd say sine is negative. We're throwing in an extra condition now. Sine is negative, cotan is negative. When does that happen? Sine is negative in the third and fourth. Cotan's negative in the second and fourth. So this must be a fourth quadrant angle. So I'm going to draw my angle in the fourth, or triangle in the fourth quadrant. So here's my theta right here. We're in the fourth quadrant. Somebody says, no, that's the reference angle. I know, but that's how we do these. We use that to represent our actual theta. Let me see, sine would be opposite over hypotenuse, but one of these needs to be negative. The hypotenuse is negative, never negative. And then you say, oh yeah, well, the y is negative because it's in the fourth quadrant. Do a little Pythagorean theorem, that ends up being positive. So now when you do your answers here, the only thing different about what we did on the first test is that we have to watch the pluses and the minuses now. This is the same stuff we did in the first unit. We just have to watch our pluses and minuses based on the quadrants now. That's the only thing that makes that a little bit trickier. And that takes care of all the new material for this unit. So we will go from there. Good times.